NASA's Perseverance rover recently completed a significant milestone by climbing to the top of Jezero Crater's western rim on Mars. This ascent marks the fifth science campaign of the mission and involved navigating some of the most challenging terrain the rover has faced since its landing in February 2021. The climb, which included slopes as steep as 23 degrees, took Perseverance 3.5 years after it began its exploration of the crater floor. The rover aims to study ancient Martian rocks at the rim, which could provide insights into the planet's early geology and potential habitability. Perseverance has already collected 22 rock cores from sedimentary layers in Jezero's river delta, representing environments that may have supported microbial life billions of years ago. These samples are crucial for future analysis as part of NASA's Mars Sample Return Program, a collaboration with the European Space Agency. As it continues its journey, Perseverance is using advanced autonomous navigation to reach specific targets like Aurora Park, from where it will explore additional scientifically significant areas. This mission is integral to NASA's broader Moon-to-Mars exploration initiative, which includes preparing for eventual human exploration of the Red Planet. NASA's Voyager 2 mission, which flew past Uranus decades ago, helped shape scientists' knowledge of the planet, but also introduced some baffling mysteries. Recently, a new analysis of the mission's data has shed light on these. When Voyager 2 approached Uranus in 1986, it offered humanity its first, and so far only, close-up look at this unique, tilted outer planet. Alongside discovering moons and rings, scientists encountered puzzling findings, particularly around the planet's magnetic field and energized particles. Uranus's magnetic field didn't behave as expected, and its behavior stood out in our solar system. Now, new research has clarified that this unusual behavior was due to a cosmic coincidence. Just days before Voyager 2's arrival, an unusual space weather event compressed Uranus's magnetic field. This squashing effect meant Voyager 2 saw Uranus's magnetosphere in a state that only happens about 4% of the time. Had Voyager 2 arrived only a few days earlier, it would have observed a completely different magnetic environment around Uranus, said Jamie Jasinski of NASA's Jet Propulsion Laboratory and lead author of a study in Nature Astronomy. Magnetospheres, like the one around Earth, protect planets with magnetic fields from the sun's ionized gas or plasma. Understanding these fields is key for studying not just Earth, but also more remote parts of the solar system. In 1986, the magnetosphere around Uranus surprised scientists. It contained intense radiation belts, second only to Jupiter's, yet was nearly empty of plasma, an unusual combination. They were also puzzled by the lack of water ions, which the planet's major moons should have produced, leading scientists to think the moons must be inactive. The recent analysis points to the solar wind as the cause. When plasma from the sun hit Uranus, it likely pushed plasma out of the magnetosphere, temporarily reducing it. This intense interaction also energized the magnetic field, injecting electrons and charging the radiation belts. This finding suggests some of Uranus's moons may actually be geologically active. Scientists now think these moons may have been releasing ions into the magnetosphere the entire time. Renewed interest in Uranus, highlighted in the National Academy's 2023 Decadal Survey, has elevated it as a target for a future NASA mission. Linda Spilker, a scientist on the original Voyager 2 mission, recalls the excitement of the flyby and the mysteries it presented. The encounter was full of surprises, and the magnetosphere measurements only gave us a snapshot, she said. This new work clears up some contradictions and reshapes our view of Uranus. Today, Voyager 2 is almost 21 billion kilometers from Earth, traveling through interstellar space. NASA's Europa Clipper mission, launched on October 14, 2024, aboard a Falcon Heavy rocket, is on a groundbreaking journey to explore Jupiter's icy moon, Europa. The spacecraft, traveling approximately 2.8 billion kilometers, aims to determine whether Europa's subsurface ocean could support life. This ambitious mission is equipped with 9 advanced scientific instruments and a gravity experiment designed to collect detailed data during 49 flybys of Europa, scheduled between 2030 and 2034. Currently, the spacecraft is undergoing meticulous post-launch instrument deployment and testing as it cruises through deep space. This process ensures the instruments, which include spectrometers, cameras, and radar systems, are fully operational and ready for their scientific objectives upon reaching Jupiter. These tools will investigate Europa's icy crust, potential water plumes, and the chemical makeup of its surface, shedding light on its habitability. The mission represents a significant step in astrobiology, targeting environments beyond Earth where life might exist. Europa's vast ocean, thought to be in contact with a rocky seafloor beneath a thick ice shell, may resemble environments on Earth where microbial life thrives, such as deep-sea hydrothermal vents. NASA scientists have identified TOI 3261b, a hot Neptune exoplanet with a tight 21-hour orbit around its star. This discovery is remarkable because such planets are rare, residing in a zone called the hot Neptune desert, where intense radiation and gravitational effects strip away atmospheres. TOI-3261b, unusually dense for its size, suggests significant atmospheric loss. Offering clues about planet evolution, scientists aim to study its atmospheric composition using advanced tools like the James Webb Space Telescope to deepen understanding of planetary formation processes.